National Paper Company must purchase a new machine for producing cardboard boxes. In trying to decide between two models that produce boxes of equal quality, they want to make the decision based on the machine that produces, on average, the most boxes. It is known that there are substantial differences in the abilities of the company's machine operators. Therefore, National Paper has decided to compare the machines using a matched sample experiment. Suppose that 8 randomly selected machine operators produce boxes for 1 hour using machine 1 and for 1 hour using machine 2. The following results seem to indicate that machine 2 may outperform machine 1. Run a test to see if this can be supported statistically with alpha equal to 0.05. Now I've got the data recorded here and have decided to do the match sample based on taking machine 1's data, matching it to machine 2, and subtracting in that order. So subtracting each one of these values, these pairs, I get difference data, -3, -5, -2, 0, -4, -1, 1, -4, -5, and -2. And since I am subtracting machine 2 from machine 1, it does appear that machine 2 is more often than not outperforming machine 1. The data is negative, indicating that the values of machine 2 are larger. Putting this difference data into my calculator, I find that the average is -2.5 and calculate the standard deviation as 2.068. I'm going to define mu sub d as the mean of the difference in values for the population of operators. And to run this test and trying to show that machine 2 outperforms machine 1, I'll set up a null and alternative hypotheses. Trying to show that machine 2 outperforms machine 1 would mean that mu sub d is less than 0. And I will see if the data evidence is strong enough to reject the null hypothesis, which is assuming that it doesn't. So the way I would set up the null and alternative hypothesis to run the test would be mu sub d greater than or equal to 0 for the assumption, and trying to see if I can prove that mu sub d is less than 0. In other words, machine 2 is outperforming machine 1 based on the operators. So step 2, I'm going to set up the sampling distribution and try to get the values I need for the sample. Center is at 0. S sub d bar is equal to the standard deviation S sub d, 2.068, and then my sample size is 10, so the square root of 10. This turns out to be 0.654. It is a lower tail test. It's a t-distribution, so with 9 degrees of freedom, that's n subtract 1, so it's 10 subtract 1. And my alpha value in a one-tail test, my alpha value is 0.05. So getting my t critical value from the table, I get a negative 1.833 that's associated there with my decision line. My rejection rule, I'm going to reject h sub 0 if t is less than negative 1.833, t being my test statistic. So I'll take my sample average, the average of the differences, subtract what I'm testing against, divided by my standard error, and that is a negative 3.82. So based on my critical value, I'm going to reject h sub 0. Since negative 3.82 is less than negative 1.833. And conclude that machine 2 outperforms machine 1, and based on the matching with the operators. Another way to make the decision in this test is to work with a p-value. I could go to the table and figure out where the p-value or the range of the p-value by looking at the test statistic, negative 3.82. In the row with 9 degrees of freedom, I can see that the 3.82 is beyond the last column where it's 3.250. So the p-value has to be less than 0.005, and that's because 3.82 is greater than 3.25 in the ninth row with 9 degrees of freedom. If I use Excel to calculate a p-value, the p-value is more accurately equal to 0.002. And since that is less than 0.05, I'll reject h sub 0 and come to the same conclusion.